Hello, everybody. So today we are going to be taking a look at the periodic trend of electron affinity. So we have in your Edmodo, go to the post that says electron affinity. We have the link for the reading. We have our practice questions, and we have my email where you can send your answers to. So let's take a look at this trend. So in most cases, when we form an anion, an ion with a negative charge, by adding an electron to a neutral atom, there's going to be a release of energy. All right, and it looks like this as far as chemical equation, because you have the chlorine atom and the electron on the left side. On the right side, you've added the electron to the chlorine atom to make the chloride ion, and we've released some energy. So the energy that occurs when a neutral atom gains an electron is called its electron affinity. So that is the energy that is released when you add an electron to a neutral atom. So when energy is released in a chemical reaction, that energy is expressed as a negative number. So the figure below is going to show the electron affinities in kilojoules per mole of all of these atoms. So electron affinities are going to be measured on atoms in the gaseous state. It's hard to accurately measure them. So these are about as close as we're going to get. All right. So the elements in the halogen group, this group right here, they gain electrons most readily. So electron affinity, besides just being the energy released by the electron, it is going to be how readily it gains an electron, how easily it gains an electron. All right. So if it has a large negative electron affinity, that means more energy is released. And it also means that it's easier for it to take on another electron. Okay. If we see the electron configuration, we can see why this is. So the outer configuration of all halogens is going to be NS2NP5. So the 5, we want to get a stable atom, we want to get 8 valence electrons. So this one has 2 and 5, so it has 7. So this is why it will easily accept an electron, because it is trying to get the 6th electron in the p orbital, thus making it have 8 valence electrons. And 8 is the magic number. 8 is the number of valence electrons in a noble gas. That's why they're stable. That's why they don't react. So, in general, our general trend is electron affinities are going to become more negative from left to right, and they're going to become less negative from top to bottom in a group. So they're going to get more negative from left to right across a period. They're going to become less negative from top to bottom down a group. So there are going to be some exceptions, but for now we just need to know the general trends. So make sure you finish your questions, turn them into me.